This is the second day of Unit 3, Section 2. We are still in text section 3.1. Today we're going to talk about solving by factoring. So in order to factor or solve by factoring, the equation has to equal 0. So if it doesn't equal 0, we're going to have to move some terms around so that it does. Factor out a GCF if possible. If you're factoring out a numerical GCF, it's going to be irrelevant because that's not going to be something that's going to affect the answer. But if you factor out a variable GCF, we have to remember to set that equal to 0, as we see in the next step. After factored, set each factor equal to 0 and solve. So if we pulled out an x, we have to set that x equal to 0 as well. So let's start by solving by factoring when there's 4 terms. So if you recall 4 terms, we're going to use grouping. So if I look at this and I group together my first set, I could take out 8x squared. So 48 over 8 is 6. X cubed over x squared is x, plus 8x squared over 8x squared is actually 1. And in the second set, I could take out negative 7. Now when I take out negative 7, negative 42 over negative 7 is 6. Bring down the x. Negative 7 over negative 7 is a positive 1. So that means my factors are 6x plus 1 and 8x squared minus 7. So this is equal to 0. And there's something called the zero product property, which is why we're allowed to do this, that says as long as one factor is equal to 0, the entire polynomial is equal to 0. So if I just set 6x plus 1 equal to 0, and I solve that, that value will make the entire polynomial 0. I'm also going to take the other factor, the 8x squared minus 7, and set that equal to 0, because these will also make the polynomial 0. So we'll add 7, divide by 8, and this is like the lesson we learned last time. When you're taking the square root, we're going to make sure that we take the positive and negative answer. And for now, we're going to just worry about the decimal. So if I divided 7 by 8 and took the square root of that, I would get about 0.94. So my 3 answers, and I know there's 3 answers because it's an x to the third, are negative 1/6, positive 0.94, and negative 0.94. So you go ahead and try this one. First, factor by grouping, and then set each factor equal to 0 and solve. Pause it, and I'll show the answer. All right, so here we have x equals negative 5, x equals 1.22, and x equals negative 1.22. We can also solve when there's 3 terms, and we have done this many times now, factored where a is a positive 1. So that's where we're finding what multiplied to c and added to b if I had x squared plus bx plus c. All right, multiplying to c, adding to b. So here we have x squared minus 4x minus 32 equals 0. So again, equals 0, that's what we want. So now we're going to find out what multiplies to negative 32 and adds to negative 4. So we could try negative 32 and 1, negative 16 and 2, negative 8 and 4, and it looks like that's my combination. So x minus 8, x plus 4 are my 2 factors. So now x minus 8 is equal to 0, and x plus 4 is equal to 0. Add 8, we get x is positive 8. Subtract 4, we get x is negative 4. So those are our 2 solutions for an x squared problem. So you go ahead and try this one. I'll pause it and show the answer. All right, so my answers for this one are x equals 8 and x equals 1. Now we're going to get into some that we haven't necessarily done so far this year, factoring when a is not 1. So that's when we have something where there's actual number in front of x squared plus bx plus c. So what we're going to do is I'm actually going to multiply a by c first, and then whatever that number is what I'm going to figure out what two numbers multiply to that and add to b. Then what I'm going to do is I'm going to rewrite the equations, substituting those two numbers I've had for the b term. So say the b term was 10 and I found it was 6 and 4. I'm now making it 6x plus 4x instead of the original 10x that was in the problem. And then we're going to factor it by grouping, because now we turned it from 3 terms into 4 terms. This is not the only way you could factor with 3 terms. You could do guess and check, which is a completely valid method. That's how I learned it. But this is probably the easiest way and helps you to make sure you didn't make a mistake right away. So we're going to solve this by factoring. We notice that there's a 7 in front of the x squared. So I'm going to start by doing 7 times 6, and I get 42. So 42 is the number now I'm going to find the factors of, and I'm looking for the pair that adds to 17. So we have 1 and 42, 2 and 21, 3 and 14, and look at that, 3 and 14 adds to 17. So what I'm doing is I'm rewriting my problem, but instead of writing 17x, I'm breaking it up into plus 3x plus 14x. So these two still combine to become 17x, so I'm really just rewriting it with two numbers instead of one. And now I can factor it by grouping. Out of the first two, I know I can take an x. I'm left with 7x plus 3. Out of the second two, looks like they're both even, so I could take out a 2. So 14x over 2 is 7x. 6 over 2 is 3. And look at that, we had 7x plus 3 in both. So 7x plus 3 and x plus 2 are our factors. And if we set each one equal to 0, we can solve each one. So we'll start by subtracting 3 here, then dividing by 7. So x is negative 3/7. And here we'll just subtract 2. X is negative 2. All right, whenever we have a number in front of the a squared, we're actually always going to end up with a fraction answer. At least one of the answers will be a fraction. All right, let's try another one together before you try it on your own. So I have 3 and I have negative 8. So 3 times negative 8 is negative 24. So I'm going to look at the things that multiply to negative 24, like 1 and negative 24. And look at that, right away, it's the one that equals negative 23. So I'm going to rewrite this negative 23x as plus x minus 24x minus 8. And now we'll group this. As the first two and x comes out, I'm left with 3x plus 1. Out of the second two, a negative 8 comes out. Negative 24 over negative 8 is 3. Negative 8 over negative 8 is plus 1. So my factors are 3x plus 1 and x minus 8. So let's use the zero product property. If 3x plus 1 is 0, 3x is negative 1, x is negative 1/3, and if x minus 8 equals 0, we can add 8, and x equals 8. And those are our answers for that one. So you go ahead and try the next one. You can pause it, and I'll show the answer. All right, so check your answers there. We could have written it as negative 1.5 or negative 3/2, and x is negative 7. So the last problem we're going to do is a bit of a word problem. You make a rectangular quilt that is 5 feet by 4 feet. So I know in here it's 5 by 4 feet with an area then of 20 because 5 times 4 is 20. You use the remaining 10 square feet of fabric to add a border of uniform width to the quilt. So what they mean is the width does not change throughout the whole thing. So whatever the width is on one side, it's exactly the same on the other, and the other, and the other. They want to know what is the width of the border. So right now it's X. If I wanted to take the area of the entire shape, that would be 4 plus X, right, for each of the widths, or 4 plus 2X. And then this length of 5 plus X, or 5 plus 2X. And if I'm talking about the total area, I'm talking about the area of the quilt we already have plus the 10 remaining square feet. So the total area we had was 30 square feet, and the total area is represented by 4 plus 2X times 5 plus 2X. So this is a quadratic that we have to solve, but in order to do that, I can't just set each of these equal to 0 because it's not equal to 0 right now. So what I'm going to have to do is I'm going to have to multiply first. I'm going to have to do the 4 times the 5, the 4 times the 2x, 2x times the 5, and the 2x times the 2x. So when I do that, I get 20 plus 8x plus 10x plus 4x squared equals 30. And I know anytime I'm going to be solving, I want it equal to 0. So I'm going to combine some like terms, subtract the 30, and rewrite it in standard form, all kind of in one step. So we had the 4x squared, 8x plus 10x is 18x, and then 20, and then minus the 30 is negative 10. So this is what we have to solve. I know that I have a GCF in here because all my numbers are even. So if I divide both sides by 2, I get 2x squared plus 9x minus 5 equals 0. And now this is a quadratic where a is bigger than 1, so 2 times negative 5 is where we're going to start to get negative 10. I'm looking at this, and 10 and negative 1 adds to positive 9. So we're going to get 2x squared plus 10x minus 1x minus 5. 2x can come out of the first set. Minus 1 can come out of the second set. And we're left with x plus 5 and 2x minus 1. So if x plus 5 equals 0, x is negative 5. But we can't have a negative length, so that's out. So then we'll focus on 2x minus 1 equals 0. Add 1. Divide by 2. And we get x is 1/2. We were in terms of feet, so we could either say half a foot, or half a foot is 6 inches. So that is the width of the border. And that is it for day 2 of section 3.2, textbook 3.1.